How weird would it be to see a car without a steering wheel? Well, with so many companies developing their self-driving cars, we may finally be able to let go of the steering wheel and let the car drive itself. So what really is considered a self-driving car? To help define how sophisticated automated driving technology is, the Society of Automobile Engineers classifies the automated systems using 5 different levels. Level 1 is driver assistance, where the vehicle is controlled by the driver. However, some assist features are present, such as emergency braking and collision warning. Level 2 is partial animation, where the vehicle has at least 2 automated functions, such as cruise and steering. Level 3 is conditional automation, where the vehicle handles most aspects of driving, but only in known environmental conditions. The driver has the ability to temporarily take their eyes off the road, but is expected to regain control of the vehicle in certain conditions. Level 4 is high automation, where no assistance from the driver is required. The vehicle is capable of performing all driving functions in most conditions. Driver can take over vehicle operations if needed. Level 5 is high automation, where the vehicle drives you. Vehicle can operate all driving functions in all conditions. There is no steering wheel necessary. So what level are we currently at? Most experts would agree that we are somewhere between levels 2 and 3. Society likes to think that we are further along with fully autonomous vehicles, but there's still a long way to go. So how do self-driving cars actually work? In order to see, self-driving cars use a combination of LiDARs, cameras, and radars. The LiDAR, light detection and ranging sensor, uses light waves to create a 3-dimensional image of the car's surrounding environment. It does this by calculating the time it takes for the laser beams to bounce back from the object. From up to 200 meters away, the LiDAR can accurately image an object within 3 centimeters. However, a top-quality LiDAR can cost up to $75,000. Thus, many companies are beginning to develop lower-cost LiDARs for self-driving cars at this time. Cameras are also a common addition to self-driving cars. Since the lower cost of cameras compared to the higher cost of a LiDAR system is a big factor for auto manufacturers to consider. Though more processing power is required to analyze camera information, the overall price of a camera-based system is still lower than that of a LiDAR system. One downside to the cameras is their decrease in performance in adverse weather conditions, where the view can be blocked or clouded. Many companies also outfit their cars with LiDARs for this reason. Usually comprised of accelerometers and gyroscopes, the inertial measurement unit, or IMU, helps track the car's relative position in order to understand where it is located in space. Since this relative position tracking accumulates error over time, it cannot be solely used to track the absolute position of the car. However, with newer GPS systems, we can now track cars within inches of their real position on the ground. The combination of both an IMU and GPS system allows the car to localize itself with high precision. Even when cars momentarily lose GPS location, such as when going through tunnels, the IMU can handle localization until GPS location is available again. So how does a self-driving car interpret what it sees? Especially for camera-based systems, deep learning is used so that the car can figure out its surroundings, such as traffic signs and pedestrians around them. Deep learning allows the programmers to create complex algorithms by training the car with lots of data. Will self-driving cars make driving safer? Well, according to the National Highway Traffic Safety Administration, 94% of serious accidents are caused by human error, which means that automating some or all of the processes in driving will significantly reduce the number of accidents. There have also been a few cases recently where motorists have either passed out or fallen asleep behind the wheel of cars with automated assistants, such as Teslas. While this is a safety hazard for distracted drivers, it's worth noting that any passenger was kept far safer than if the vehicle had no automated assistance. Tesla, in fact, has placed measures which require motorists to be attentive when using the autopilot. The driver is regularly reminded to stay attentive, and if those warnings are disregarded, then the autopilot cannot be engaged.